Let's have a look through some of this maths for today, and let's see where we're going with it, what we need to know. Interesting question, if you will. 4 large circles and 5 small circles fit exactly inside this rectangle. Because it's exactly inside, I know that the length of 5 of them is exactly the same as the length of 4 of them. That's an important fact to know. Okay, so the diameter of the large circle is 17.5 centimetres, 17.5. Diameter is the distance from one edge to the other edge through the centre of the circle. So it's exactly how wide a circle is. It says here, calculate the diameter of a smaller circle, so I need to work out this one. Because it's not actual size, because it's not drawn to scale, I can't use a ruler, so I'm going to have to use some maths. If I want to work out the total length of this, what are we calling it? Rectangle. I was wondering if it was a box. I'm going to have to do 17.5 times by 4. 17.5 multiplied by 4, which is going to give me an answer of 70. Well, that means that my distance here is 70 centimetres. Now if I want to work out the diameter of one of the smaller ones, there's 1, 2, 3, 4, 5 here, so I simply need to do 70 divided by 5, which will give me an answer of 14. Question number 2 talks about having a kite, and we're starting to use some coordinates here. We've got A, B, C and D, and we need to know the coordinates of point D. So we know in our axes we have our x-axis and we have our y-axis. We have our x-axis, we have our y-axis. The way that we write coordinates is the first number that you write is your x. And the second number that you write is your y. Okay, we can check that by going, okay, well if we draw a line through A and C, they're at the same level, they have the same y coordinate, which means that they are at y4 here. Okay, so if I get rid of that, and we think about this, we're after coordinate D. So to start with, we know the x-axis, that's in line with B, which means that this is going to be at 5 on the x-axis. So the first coordinate is going to be 5, and it needs to be in brackets, and both coordinates need to be separated by a comma. Now the slightly trickier thing is working out the y coordinate, but it's not impossible at all. I need to use my knowledge of shape to know that the distance from here to here is going to be the same as the distance from here to here. Now if I look at the difference in my y coordinates between these 2 points, my y coordinate here for the first one is 6. My y coordinate here is 4, which means that between point B and point A, my y has changed by 2, it's reduced by 2, it's come 2 further down my axis, which means if I continue all the way down to point D, the same thing is going to happen because of the nature of the kite shape. So that's going to be 2 on my y-axis here. Okay, so that simply means my coordinates for D are 5, 2. Question 3 shows that this time our shape is a parallelogram. Again, we've got our axes, which we should be spotting here. We've got our y-axis, we've got our x-axis. There's no numbers because that would be far too easy. Here now we need to work out the coordinates of point A. It's going to be very similar to the last one, but we just need to apply ourselves a little bit to this. So first of all, if I take a horizontal line across and I line that up with my point here and with point A, you can see that those lines are completely lined up, which means that the y-axis, the height here, this side, is going to be the same for this point and for point A, which means that to start with, without really doing a huge amount of thinking, I can put my y coordinate in, which is going to be 27. Okay, now for the next bit, I'm going to need to do a little bit of thinking here. So, what I need to realise with this one is that in the same way that a kite has some certain properties, this parallelogram does as well. Now, The reason I put these lines on here is because the distance from this point to this point is going to be the same as the distance from this point to this point. Okay, and if I line this up here, we'll see that there. Okay, now all I need to do is I need to inspect my x coordinates at this point here. So I'm going to inspect my x, I'm going to inspect my x, and I can see actually at this point these change by 5. So it's gone 5 more along the x-axis from here to here. That means the same thing is going to happen here. It's going to increase by 5. So if I look at my x coordinate here of 35, it's going to follow the same procedure. It's going to increase by 5. That means that that one is going to be 40, which is going to give me the coordinates for my point A here. My point A here, which is going to be 40, 27. Okay, let's have a look at question number 4 and 5, last two we have here. Shaded shape here is an isosceles triangle. You'll notice you're always given the name of the 2D shape. It's precise with you. That tells you you're going to need to use your shape knowledge. There's going to be some important facts there that are going to tell you something interesting. You need to write in the missing coordinate. So again, if we come back to our graph, we have our y, we have our x, we've got x and y, we've got x and y, we've got x and a missing y coordinate here. So this one's fairly straightforward because you're given the x coordinate. You know that's 6 because it stays in line. You're not given a y coordinate, so that's something we need to work out. Now, what we can know about an isosceles triangle is that the distance from here to here is going to be the same as the distance from the corner to the middle point here. So corner to middle point, corner to middle point, middle point to corner. Those two are going to be the same, they're going to be identical. So if I want to work out what's going on here, I simply need to inspect how the y coordinate changes from the bottom to the midpoint, because I'm given both of those y coordinates. If I look at the y here, it's 8. If you look at the y here, it's 18. That's an increase of plus 10. That means that exactly the same is going to happen between the midpoint and the top point. And I know that, I'm confident in that, because this is an isosceles triangle. That's why giving that information at the beginning is really important. So if that was plus 10, this is going to be plus 10. So this one up here is going to be 28. Okay, last but not least, this diagram shows a rectangle. We need to calculate the angles x and y. Now there's a few things we need to know about this that will really help us out. And these are to do with opposite angles, and they're also to do with something called z angles, which are quite interesting. If you have two parallel lines, and you draw a line between them, so it makes a z, hence the name z angles, or you do it the other way around, and you do it, it doesn't have to look like that, or they are vertical and they cross, you get an interesting relationship with the angles, which is that this angle here is the same as this angle here, this angle here, same as this angle here, this angle here is the same as this angle here. Okay, and that's just a relationship, that's a property of shape, and that's really important to know. For that to happen, these lines have to be parallel. If they're not parallel, you cannot assume that the angles will be the same. Knowing that now, I can overlay that style onto my diagram here. So if I do this, we'll spot that we've got some angles here, which means that already I can tell you that that one here in this corner is going to be 36 because of here. So I can start labelling this up. We're going to have a 36 degrees. Okay, fine. Does that help me? Yes. If I know this angle here, I know this angle here, because this triangle inside my rectangle that I've been given is actually an isosceles triangle, which means that the two corner angles are going to be the same. So this is 36 degrees, which actually means that this is 36 degrees as well. Now if I know that, I can work that out because of my knowledge that all the internal angles in the triangle add up to 180 degrees. So I'm going to have 36 add 36 gives me 72 degrees. If I've used 72 degrees for my 180 degrees, that means I have 108 degrees remaining for my angle X here. Okay? So that's one part of it dealt with. I'll remove these bits here. If I'm looking now for angle Y, well, let's have a think about that. My angle Y, I can actually do a bit of changing these around. So let's flip this one here down to here. Let's flip this one here over to here. And what we'll notice is we have ourselves another Z angle. Now, if I jump into here, that means that, thinking about these, this angle here is going to be the same as this angle here. And actually that's angle Y that I want, isn't it? The other thing that I need to think about here that's going to really help me out is our knowledge of right angles. And so actually we know that it's because it says it's inside a rectangle, and again, key, it gives you all the information you need. Because it says it's inside a rectangle, I know all the internal corners are going to be 90 degrees. If I've got a 90 degree angle here, but I've already used 36 degrees of it, whatever this angle here is whatever is left. Okay, that gives me my 54 degrees. 54 plus 36 makes 90. Using my knowledge of Z angles, if this one is 54, it means that Y is 54 too.